Have you ever wondered that whenever we solve a linear system of equations in two variables, sometimes we have exactly one solution, sometimes there is no solution at all, and in some cases there are many solutions? Why does it happen? So, in today's video, we are going to explore all these three different possibilities and the required conditions to recognize each of these cases. So, let's get started. My first example would be 2x plus 4y equals 2, 4x plus y equals 11. First of all, I'll compare the ratios of A1 over A2 and B1 over B2. A1 over A2 means the ratio of the coefficients of x. That means 2 over 4. And 2 over 4 will give me 1 over 2. B1 over B2 is the ratio of the coefficients of y. That means 4 over 1. Are these ratios equal? Of course not. So, A1 over A2 is not equal to B1 over B2. In such a case, when the ratios are not equal, the given linear system has unique solution, or you can say exactly one solution. And this system is called as consistent system. Whenever there is a solution, the system is consistent, as well as it is called as independent system. Why it is called as independent? Because these two equations are totally different, and when I will draw their graphs, the two lines will meet at exactly one point, and that one point is the solution of this given linear system. Now, since this system has one solution, let's find out that solution using the elimination method. So 2x plus 4y equals 2 and 4x plus y equals 11. Let's name this equation as 1 and this as 2. As you know, what is elimination method? We eliminate one of the variables at the first step. I will be multiplying this equation with 4. So 2x plus 4y equals 2. First equation stays the same. When I multiply this whole equation with 4, 4 times 4x is 16x plus 4 times y is 4y equals 4 times 11 is 44. Now, we will subtract the equation, so change the signs of second equation. 2x minus 16x will give me minus 14x. 4y minus 4y 0 equals 2 added to negative 44 is negative 42. Eliminate this minus 14 to get the value of x. So divide by minus 14. Minus 14 divided by minus 14 is 1. So x comes out to be minus 42 divided by minus 14 is 3. So that's my value of x. Put this x equals 3 in any of these equation. I will be putting in the first one. So 2x plus 4y equals 2. So 2 times 3 plus 4y is 2. So 4y equals 2. This 2 times 3 is 6. This plus 6 when shifted that side will become minus 6. So 4y equals minus 4. Divide by 4 and I get the value of y as minus 1. So my solution is x equals 3 and y equals minus 1. And you can see that this given linear system has exactly one solution, x3, y minus 1, which sometimes is written as this also. Let's explore the second possibility. 2x plus y equals 5, 4x plus 2y equals 6. Let's compare the ratios. A1 over A2. It's the ratio of the coefficients of x, so 2 over 4, which is 1 over half. B1 over B2, the ratio of the coefficients of y, which is 1 over half. Okay, so the two ratios are equal. So in this case, let's compare the third ratio as well, C1 over C2. C1 over C2 is the ratio of the constant terms. What are those? They are 5 over 6. So what do I get? I get A1 over A2 is certainly equal to B1 over B2, but it is not equal to C1 over C2. These two are equal, but they are not equal to this 5 over 6. In such a case, the given linear system has no solution. And when the given linear system has no solution, the system is called as inconsistent system. No solution means inconsistent system. Let's prove this by solving these two equations by elimination method. So 2x plus y equals 5, my equation number 1. and 4x plus 2y equals 6, my equation number 2. Let's make the coefficients of y equal. So for that, I will multiply this equation with 2. So 2 times 2x is 4x plus 2 times y is 2y plus is equal to 2 times 5 is 10. The second equation would stay the same. 4x plus 2y equals 6. Let's subtract them. 4x minus 4x is 0 plus 2y minus 2y is 0 equals 10 added to minus 6 is 4. So I get 0 equals 4. Is this possible? No, 0 is absolutely not equal to 4. So it is not possible. And why does this happen? Because this linear system has no solution. Because I reached a step where it is showing me that 0 is equal to 4, which is not true. That is why this given linear system has no solution and it is inconsistent system because there is no solution for this kind of linear system. The third and the last possibility. My equations are 2x plus 3y equals 6, 4x plus 6y equals 12. So let's compare the ratios a1 over a2, which is equal to the ratio of the coefficients of x. So 2 4 over 4, which is 1 half. b1 over b2 is equal to 3 over 6, ratio of the coefficients of y, which is again 1 half. And c1 over c2, the ratio of the constant terms, which is 6 over 12, and which is again half. All the three ratios are equal. So in this case, again, the system is consistent because all the ratios are same. The system is dependent and the given system has infinite solutions, infinitely many solutions. Whenever there is a solution, either one solution or infinite many solutions, the system is called consistent. Why this is called as dependent system? Because the two equations are dependent on each other. You can easily see that the second equation is just the multiple of first equation. So the two equations are dependent on each other, and that's why this linear system is dependent. It has infinite many solutions. Let's prove this by solving these equations using elimination method. So 2x plus 3y equals 6, my equation number 1. 4x plus 6y equals 12, my equation number 2. Let's make the coefficients equal. So I will multiply it by 2. So 2 times 2x is 4x plus 2 times 3y is 6y. 2 times 6 is 12. My second equation would stay the same. And now let's subtract these equations. 4x minus 4x, 0. 6y minus 6y, 0. 12 added to minus 12, 0. So what did I get? I got 0 equals 0. Is this a true statement? Of course, 0 is equal to 0. Now, since there is no specific value of x and no specific value of y, that is why this linear system has infinitely many solutions. Why does this happen? Because basically these two equations are same. One of the equation, like this second equation, is just the multiple of the first equation. If you multiply this equation by 2, like I did here, I get both the equations as exactly same. So when the equations are dependent on each other, like multiple of one of them is the multiple of another, the equations are basically same. And in that case, we have infinite many solutions. The system is called consistent and it is called as dependent as well. Thank you for watching. What's next? In the next video, I will be drawing the graphs of all these three types of solutions to prove that how we can get exactly one solution, no solution, or infinite many solutions from the graph as well. If you have liked the video, please hit the like button, subscribe to my channel. Thank you.